Let's start our quick review for chapter 6 and 7 for our test tomorrow. Chapter 6, we had two sections where we talked about inverses and we talked about solving trig equations. So with our inverses, we have some ranges that we need to understand or know, and to make life simple there, we simply used the calculator to come up with those. The bottom line is that anytime a trig statement is written as an inverse, I can't get this thing right. If we're written as an inverse, we're looking for a hard time here. If we're written as an inverse, we're looking for a single answer here. So this would be a calculator version because 0.5512, I know that's hard to read, but I couldn't get this thing to write very well. 0.5512 is not on our unit circle, so we'd simply type in the inverse sign of 0.5512 and come up with either our degree measurement or our radian measurement based on whether we want degrees or radians. If we had those values that were on the unit circle, such as a negative square root of 3 over 2, again, we're looking for just the one answer. So even though they're on the unit circle, I would suggest still using the calculator to come up with those and then just determine whether or not we need the answer as a negative 60 degrees or as a radian of negative pi over 3. So we can use our calculator for those because the calculator again has those pre-programmed ranges to tell us that we only want one solution and not two. Anything written as an inverse, looking for those one solution. And we'll have a combination of those between degrees and radians, between those that are calculator based and those that would be unit circle based, even though we're still using the calculator to come up with those. But the bottom line is we are looking for one solution as we go through there. There will be some of those that will be what we call compound functions, so we have to understand the difference between a ratio to an angle and an angle to a ratio. So we might have the sine, try that again, of the inverse cosine of 0.57. 0.557. Okay, so we do this work first. This would convert it to an angle, and then our sine would convert that angle back to a ratio. Bottom line here, these can all be done in the same mode, so I put these in degree mode and just go ahead and do the work there because it's going to give you the same calculation all the way through. We're probably going to want our angle in degrees. Okay, so we have those. We might have the inverse tangent of the sine of 80 degrees. Now you can see here, maybe you can't because I didn't write very well, of the sine of 80 degrees. Here it's converting an angle to a ratio. Then this inverse converting that ratio back to an angle, so we should ultimately wind up with an angle measurement here based on what we plug into our calculator. So those will be 4 or 5 of those types. Then we'll have some of those where it say don't use the calculator, and they really don't mean to use a calculator because we would say we have the sine of the inverse tangent of, we'll say, 3/4. Okay, so this is inverse tangent, -1. Okay, so in this scenario, same idea, we're converting this ratio to an angle, and then taking that angle back to a ratio, so we want our answer as a ratio, which means we simply find x, y, and r here, and go ahead and find our value from there. So tangent is y over x, which means I have a 3, 4, 5 triangle, and I simply find the sine of that. Well, sine is y over r, so our answer is 3/5. We'll have a couple, 3, 4 of those. One of those will probably include a double angle. So we might have the sine, having a hard time with this today, of 2 times the cosine, inverse cosine of, let's go, we'll say the same 3/4 here. Okay, so notice right here, the inverse cosine would be converting that ratio to an angle. So we'd have sine of 2 times an angle, which is our double angle identity, or 2 sine A cosine A. So we start out by finding x, y, and r for our angle. This would be a 3 and a 4, so this would give us a square root of 7 for our y. 3 squared subtracted from 4 squared. And I'd simply make those substitutions. Once I have those, 2 times the sine is square root of 7 over 4. And cosine is 3 over 4, and we just multiply straight across. Okay, so that would be probably the most commonly missed one there on the first section that we had. Once we got done with section number 1, we went ahead and we solved some trig equations. I believe there are 3 of those on the test, and one of those will be a trinomial, so I'll start with that one. Let's say I have sine squared x minus 2 sine x minus 3 equals 0. So here's a trinomial. We would factor this, and we'd have sine, this isn't going to work out very well, so let me just start all over with this. I picked some bad numbers to work with. I'm going to use the same numbers, but I'm going to use tangent. So I'm going to say tangent squared minus 2 tangent squared minus 3 equals 0. It's still a trinomial, so we set up our 2 blank sets of parentheses. And to get tangent squared, we could take tangent times tangent. To get 3, we could take 3 times 1. I want that to be a negative 2 in the middle and a negative 3 here, so I'm going to go negative 3 and a minus 1 equals 0. Tangent x equals, or minus 3. Equals 0. And tangent x minus 1 equals 0. Solve for tangent. Tangent equals 3. Tangent equals 1. I'll start over here because 1 is on our unit circle. We can find those on our unit circle. There's going to be 2 answers. There's going to be 45 and 225 worth in degrees. If we're in radians, it'd be pi over 4 and 5 pi over 4. Over here, 3 is not our unit circle, so now we use our calculator. We type in the inverse tangent of 3 to get our angle measure. And once we have that, that would give us our angle probably in quadrant 1 because this is positive. We'd also find that same reference angle in quadrant 3, and that would be our 2 answers over here, so we would have 4 answers for this problem. There'll be one of those. There'll be one that might be pretty straightforward, such as 2 sine theta minus 1 equals 0, and maybe one where we have to do some factoring of greatest common factor. So maybe I have cosine theta times sine theta minus cosine, or let's say 2 cosine theta equals 0. Factor out a cosine and set each factor equal to 0 and solve. Just note that with each of these problems, there's 3 or 4 that we have multiple answers, so make sure you include all of your possible answers. Once we got done there, the rest of our work was out of chapter 7 with our law of sines and law of cosines. Law of sines, A over the sine of angle A, B over the sine of angle B, and C over the sine of angle C. That's our law of sines. We can cross multiply with any of these two ratios to solve for missing values. Does not need a right triangle for law of sines. It works for any triangle. We did have the ambiguous case with that. Anytime we have two angles and one side, we have to check for a second triangle with the law of sines. Okay, so there will be one of those ambiguous cases on the test more than likely based on two angles and one side. We went through that step process, solve your first obvious angle, subtract it from 180 and so forth to find your second triangle. We've gone through that. We had our law of cosines. Probably just write up the one version here. Maybe not. Maybe I'll write up all three. B squared equals a squared plus c squared minus 2 ac times the cosine of b. And c squared equals a squared plus b squared minus 2bc times the cosine of c. Noting, first of all, obviously we have the law of cosines here, so we have cosine in here, but the side I'm solving for is the side opposite the angle I use in the formula here. So we'll have one or two problems using the law of cosines. We'll have a couple problems that, I don't want to say a couple, three. There's three problems, I know that for a fact. Three problems that are applications, word problems, where you have to draw the diagram and choose whether you use the law of sines or the law of cosines. What else will we have? Area of a triangle. Probably give you these formulas. One of those is 1/2 AB times the sine of C. Simple substitution will get us the area here. Just remember areas in square units. Another version is 1/2 of one of our sides, so I'll use side A, times each of our three angles. So we have three angles in one side. So sine of B, sine of C over the sine of A. Noting the side we use here is the side opposite the angle we use in our denominator here. And then our other area formula was for all three sides that were known. This was a two-step process. We found a value we labeled as S first. S was 1/2 of our three sides added together, A plus B plus C. Then the actual area itself was the square root of S times S minus A times S minus B times S minus C. So we take each side, subtract it from S, and multiply each of those four individual products together, take the square root of that. All of our areas are in square units. So if a label isn't there, our label should be square units. And that, I guess, is real quickly what we can expect to see on our Chapter 6 and 7 test. One of these word problems is somewhat challenging, I will tell you that up front. Backtracking, more points are probably missed on these three than I think should be, especially one like this one right here. So make sure we know how to use values off of our unit circle and how to use our calculator to come up with multiple answers. I will probably make this one a little bit simpler and say it's between 0 and 360 so we can put our answer in degrees. One of these two will be in radian measure, so make sure you can put your radian measure on those. And then back here, a lot of calculator usage on these, and then we have these 3 or 4 that will have our ratios that we can use as we go through. But that should give us a pretty good idea of what to expect on the test.